Oh, I just realized I did not press the go live button. That is not ideal. Wait, so can you guys see like the last like 20 minutes of doing stuff? That was a massive error on my part. I do apologize, guys. Um I've just been like going on about fucking stuff for ages. I was wondering why everyone was saying like it's 7 minutes late when I'd already started the stream. Wait, let me check if you guys can actually see the video before this, because I've been recording for like the last 20 minutes and I only just realized that you can't see it. Um, I am a zoomer, guys. I do apologize. Okay, let me see if you guys can actually go back and see what I've been going on about for the last 20 minutes. Okay, so no, you can only see like the last 45 seconds. That is actually miserable.
Oh, I just realized.
Well, I do apologize, guys. But yeah, I know for next time not to do that. But now we're started, so that's good. But I've just been like memorizing the way that B plus trees work, so I can then start working on a my own B plus tree. So I just realized like I need to go and explain everything again. So in a database, usually like we need to store the data on the disk, because obviously storing it in memory is going to be way too intensive. Because if we have like 1 million users, you can't just store those in memory. I know that's very hypocritical because of my file explorer where I stored the entire cache in memory, but I've learned from my mistakes. So this time we're going to actually store the B plus tree in disk, or at least we're going to try to do so. So the way that we're going to do this is we're going to essentially map the B plus tree in memory, and then when we insert, we'll just update the disk. So we'll just have a bunch of files in the file system. Usually, and I'll show you, we could usually use a disk structure. Let me look up for the Wikipedia article. Disk storage, whatever. Usually, actually no, this is not a very good example. Disk sector. Usually we'd use like disk blocks, disk sectors, all that stuff. I'm not very familiar with that. So I'm not going to be touching that. I'm just going to be doing it with the normal file system, which is probably going to be slower than this could be. But also I have 5 days to do an entire database management system. So I thought that I would just get along with it and just do it a silly way. So yeah, I had a bunch of notes of how these worked, but I was just memorizing myself the last 20 minutes that I forgot to actually, start the stream. But yeah, apologize for that again. Let me know if the music's too quiet or too loud, or if you don't like it. As long as it's copyright free, I can change it. But yeah, what I was looking at right now is insertions, how the insertions work on this tree, and then I was going to try and figure out in my head how to do this, because I'm not very familiar with like leak code or algorithms, anything like that, to be honest. I've not like done an interview for a programming job or anything like that. I've kind of just been experimenting and learning about it to start with. So my implementation of this is going to be very poor, but if you guys could help me along the way, that'd be amazing. But if you want to watch me suffer, that is also okay. I am willing to suffer for the entertainment of you guys. Did you say the music's a little bit quiet? That is my bad. I'll turn it up for you. Because I can't actually hear it myself, because it was annoying me, to be honest. But I've just got like a YouTube video playing in the background with the music playing. Let me know if you can hear it now, if that's a bit better. I mean, I can hear it through my headphones, so... database structures in Rust are rough. Yeah, well, that's why I'm doing it. Because everyone likes watching programmers suffer. That's what I've learned from doing YouTube for a year. So anyway, we were learning about B plus trees. So I was just looking at what happens. So this is going to sound a bit confusing because there's a bunch of context missing, but essentially a B plus tree is structured. So we have the root node, and then we have pointers on the left and right. And on the left is if the value is smaller than, for example, 13, and on the right is if the values are larger than 13. So we store these, what are called leaves or nodes, I believe, on the left and right, and these are usually associated with data as well, which we will figure out. So that's how these work. This is how we can really quickly search a B plus tree, and these were originally designed from B trees. So if I show you a B tree, pardon me. So a B tree is, I think a B tree is more designed for storing in memory, whereas a B plus tree is designed for storing on disk, meaning that we can handle a lot more data in the database on disk because we are limited to essentially that hard drive's capacity. As long as the B plus tree is implemented in an efficient way, then this is very effective for things like database management systems. So what I was currently looking at is, because we can have a maximum number of keys at the top and a maximum number of leaves. I understand what happens if we have a maximum number of leaves. I'm not sure about a maximum number of keys, so that's what we're looking up here. So what happened is we're copying up 5, I believe, because this was the insertion value. Actually no, I think it was because it was the middle value. So he was explaining, oh okay, so well, next split the root. I don't know if this is, I don't know if I was looking at the right thing. Some people say the music's a little too loud. Okay. Is the music too loud, or is it just right? Let me know. Half of the stream is going to be me adjusting the music for everybody's liking, isn't it? Let's get back to this. Okay, so let's see. Let me just check that's... Yeah, okay, cool. So... let's see. Yeah, so we split the root node and then we move it up. Okay, and then we don't copy 19. Okay, that makes sense. But what happens then? Is it just like... I think it's just its own root with a left and a right. Yeah, that makes sense. So I have a fair understanding of B plus trees. I don't know how to do deletions. I believe that's just insertion in reverse, but we're going to start by at least trying to implement this in Rust and see what happens. So I do apologize, bear with me. Number one, I've not been doing Rust that long, I'm not very good at Rust. Number two, I'm not very familiar with data structures and algorithms, so my implementation of this is probably going to be quite slow. I'm probably going to have to cheat and look up how to do this. But we're going to attempt our own implementation. And I'm going to suffer along the way. Okay, so yeah, what I already did while I wasn't streaming, unfortunately, was I just made a struct called a tree node. I suppose, do we need a tree root? I'm trying to think in terms of structs, like how we're gonna split this up. So we could get our, I was gonna use Microsoft Paint. We could get our trusty Miro up. And let's see, if I increase the thickness, there we go. I don't even need that, I can just use boxes, I think. So we have a look at the example here. Let's look at an example of a B plus tree. Okay, let's use this one. So we have a left and right, but I think leaves will be separate to a roots node, because we'll have like a root and then we'll have a node. So I guess we'll split it into nodes and leaves. I don't even know if that's the correct terminology. But yeah, I don't know. Let's just stick to nodes and leaves. So this would be a node, this would be a node, all the light blue ones are a node, and then the dark blue ones are leaves. This is actually a B, is this a B plus tree? Maybe I'm being dumb. Let's not, this is a better, yeah, because these are just, okay, so we'll have probably nodes and then leaves. I don't know about this pointing to the next pointer, because surely if we're doing a search that wouldn't matter. I think we're going to stick to probably very simple queries instead of making them really complicated for now, because to be honest, that's going to take a very long time to perfect, especially when I don't really understand these structures. So a lot of this is going to be improvised. This isn't going to be, this probably isn't going to be a usable, database management system. It's probably going to be something that I just slap together in the 5 days I have and see what comes out of it. Because, yeah, I mean, I don't really have a lot of background in how disks work or B+ trees or algorithms, so it's literally just going to be a bunch of improvised shit that's hopefully going to be entertaining for you guys. So yeah, I suppose we'll start by having a tree node and a leaf node. That's probably fine. And then I suppose we need a left and right, which is just a pointer to... That's the thing, is it can be a pointer to either a leaf or another, although that's not true, because I believe it's just 3 layers. So on the top layer we have the root, on the middle layer we have the nodes, and then at the bottom we have the leaves. So maybe we should have like a root node as well. And then we'll just split the structure into 3 layers. I could be doing this absolutely wrong, but I hope this is entertaining enough. But we're gonna try our best to actually get something good done. How's the quality, by the way? I live in the UK, so I'm limited to like 25 megabytes per second. Hopefully it's okay for you guys. I was passing by and I just wanted to say don't give up. Rome was not built in 2 days, same goes for DBMS. Thank you very much, I appreciate it. Yeah, we're gonna do our best to get this done in like 5 days, but likelihood is it's gonna be really shit, but that's fine, because I think that will be entertaining enough for you guys. So yeah, I'm gonna stop going on because I could probably procrastinate this the entire stream. That's what I do by talking, is that's just me procrastinating because I don't want to think. But yeah, I suppose we'll have a left and right, so we'll have the value, and also the root node can have a maximum value. I think we're just going to start by making a constant, because we have, I think it's called a depth. There is also like a depth, and then we have like a maximum, and there's a bunch of different values. I'm trying to keep it simple. A lot of this is going to be improvised, so I could do this very wrong and mess it up. But yeah, we have a depth, and this essentially decides how many items a pointer can contain and how many items a tree can contain and stuff like that. I suppose the best way to do this is, because there's only gonna be one root, or is it? No, there can be multiple roots. Okay, there can be multiple keys in the roots. Okay, so we'll have like a list, we'll have an array of root nodes, I suppose, and then each of these will have a value and a left and right. But let's keep the depth, let's just keep it 4 for now, because that was what was done in the example as well. So we're just going to say the depth is 4 for now, that's fine. And then we'll say that these will have a left of a tree node. And does this need to, I mean, ideally this would be a pointer, but then I have to deal with lifetimes, and I'm not very good at Rust, to be honest. The fact that I already used the semicolon here, where it's meant to be a comma, that would be my TypeScript, my TypeScript brain. And then we'll just have a value, which in this case is just going to be, I guess, 932. We'll change this to text later, but we're going to keep it simple with just numbers for now. And then the same here, we're going to have a left of a leaf node and the right of a leaf node. I think, yeah, these can all have left and right, so that's fine. And then we have a 932 here. Okay, so, and then the leaf node, this is just gonna, I mean, yeah, this just needs a value, I believe. So I don't think we even, I mean, yeah, we should actually, we'll have a value, and then this will point to data later, so this is fine to be a struct. And then we're gonna have like a, I guess, a B tree struct, or a B plus tree struct. What do I call it? A BP tree? That's fine. And then in our BP tree, we will have, we'll have the root node, which is just going to be a vector of root nodes. And this could be a hash map. It probably should be a hash map. Yeah, because a hash map would actually make a lot more sense, I think. Yeah, I mean, I apologize, as I know I could use like polymorphism to limit the amount of structs I have, but I just want to, you know, keep this simple for my brain, because otherwise I'm just going to absolutely overload with information. But we can always optimize this later if need be, so that's absolutely fine. Okay, so let's see. Yeah, we'll use a hash map. I think that makes a lot more sense. I mean, we don't need this for now. We're using hash maps, and we also don't need the values if we're using hash maps. So yeah, let's make this a hash map. Yes, that one, please. And then we'll have trees, or tree, hash map tree nodes, and then we'll just have leaves. Is it leaves? Leaves? We'll call it leaves. Okay, so we'll just make that for now. We'll just make it a hash map of integers. What's going on? Oh yeah, of course. We obviously need to have the value, which is always going to be 932 for now. This can be. That's a good point, because the tree and the leaves is actually going to be a vector of like blocks. If you look here, it's actually, what's a good example? Here we have like 2 tree nodes and then 5 leaf nodes. So they're actually separated like that. So in that case, we'll have a vector of hash maps. This is getting very complicated, I apologize. So this can just be a hash map because we can only have one root. That's fine. Struct takes it. You guys are probably laughing at me for doing this completely wrong. Will I add a GUI? I mean, right now I don't think a GUI is something that I can do in 5 days for a database management system, because the fact is, like, the database management system itself is gonna take, like, I mean, if I wanted to do this properly, it would take months. I'm doing this in 5 days. A GUI is probably like the last thing you want for a database management system, because first you want to have like actual functionality with like SQL and stuff like that. That's how they usually work. And then, because like most people who use Postgres in production, as far as I know, they don't really use a GUI. Usually they just use raw SQL because it gives them a lot more control and freedom. So a GUI is really like a very low-hanging fruit for something like this. But a GUI would also be very cool, and something that I probably won't be able to do in 5 days, but something in the future would be really nice to have is, you know, live updates. So, you know, on the back end, that if you want to, for example, if you have a Postgres database, and I think Firebase is better with this, but if you have a Postgres database of posts, for example, and then you render those posts on the front end from the back end, you just say, you go to like /API/posts, for example, and then you get a list of posts. But the thing with these posts is that you don't actually know when they get updated. You kind of just have to guess and say, oh, every 5 seconds update the posts, or every time they refresh, update the posts. But I wanted to have a feature where, like Firebase and probably some other databases do this, where you just connect to a TCP server and then it will just live update the data as it goes. And I also know that while writing this, I'm going to introduce a lot of security vulnerabilities. But as I said, this isn't meant to be an actual thing, it's just meant to be a fun project. So let's see. So I've done something horribly wrong with this hash map, and I'm trying to figure out what I've done wrong. Supplied one generic argument. What do you mean? I supplied two. Struct define. Oh wait, I didn't save it. I am dumb. Cool. Okay, so and then these would be a vector of hash maps because there are multiple trees that are gonna be here. So I guess tree nodes and then leaf nodes to just make this a bit more clear. And then this will just be a vector of, I guess, just integers for now. Actually, no, we'll have a vector of vectors, and this will change later, but that's fine for now. What have I done? What have I done wrong? Oh dear. No, I don't need that. There we go. Wait. There we go. It's sorted now. Okay, and then a leaf node in this case is just going to be, I guess. So maybe we should make this a bit clearer and have like a root, which is going to be a hash map of i32 root nodes, and then we'll have a tree nodes equals a vector of tree node keys. I don't know what to call these. I guess tree keys. I don't even know. Tree keys. I don't know what to call these. What do you call these? What's the terminology? Like whoever said it, I don't remember who said it, but the hardest things about programming are genuinely variable naming and caching. Also, I'm getting a loading bar on my stream. I'm hoping that you guys are viewing it okay. Will the project be on GitHub? Yeah, probably. And lots of logging. Yes, logging is probably the most easy and most fun part of programming. But unfortunately, in order to log something, you need to make the program first. So it's, yeah, I mean, to get to the logging stage anyway, it's going to be a painful process. Increase the font size for us on mobile. I mean, I can't really change the, I can change the text size, if that helps you guys. I can zoom in like that. I'll do that for you. But I can't change the, yeah. I can't change it specifically for mobile if that's what you meant. I don't think you meant that though. Okay. Don't spam or I will use the magic wand and get rid of you from my stream chat, Mr. Fondant. Okay, so let's see. Okay, so I'm confusing myself here. This is what I do when I'm programming. I like try and think so ahead that I actually just end up confusing myself and probably everyone who's watching. So let's see, tree keys. We'll just call them tree keys for now. That's fine. Or not tree. I mean, yeah, we'll call these tree nodes, and then this would be a tree key or a tree item. A tree node item, that's what we're going to call this. A tree node item. And then here we're just going to say tree nodes, which is going to be a hash, or a vector of hash map i32 tree node item. That's fine. And then we'll just make this a vector of tree nodes. And then this can just be a leaf node, and then this just can be a vector of i32s, and then we'll make this a vector of leaf nodes. And then the hash map root nodes, I guess this is a root, which is a list of root nodes. I guess we'll call this root keys, which is fine. If I mess this up, hang on. A hash map of, no, we just want a hash map of, we just want root, don't we? That's fine, and we don't need this. If so, we haven't used these, which is fine. I do apologize for being so slow. I am just absolutely dog shit at Rust. Let's see. Yeah, I will upload this as a unlisted video, so if you want to watch this later on, you can do, as I'll just put it in a playlist, and then you can view that playlist and see the stream. Okay. Cool. So, what have we done in the last 42 minutes? We have made 3 structs. This is why Rust is hard. Well, this isn't Rust's fault. This is why I'm a shit programmer and why I'm probably not going to get employed. Is I am really slow when it comes to these kind of things. But I'm also trying to plan how to write a B+ tree without ever seeing code for a B+ tree. So please do bear with me. Quick question: where are you defining the struct of leaf node? So the leaf node is now not a struct because. So the leaf node is just a type, which is a vector of i32. So the leaves are these items here, and because they don't point to anything, they're like at the bottom of the tree. They will eventually point to something, but at the moment they're just at the bottom of the tree. They're just a vector of i32s, or a hash map of a vector of i32s. What I just realized is that a hash map of hash maps isn't going to work very well. Although this is a vector, so that's fine. Never mind. I just confused myself again. You're going to see a lot of that in this stream. So, let's see. So, now we want to consider how we're going to initialize this. So, let's at least try and make a function here. So, let's say a pub function insert. And we'll also have we'll have to implement like a display trait to make this easier. What am I doing? Why am I'm so used to classes and stuff in JavaScript. Right, I need a impl bp tree, and then we'll have a pub function, and then just insert, and then we'll just have item. And then this item. So first we need to check if the root, although the thing with using a hash map for the root is it's going to be very difficult to get the length. Wait, can I get a length of a hash map? Get length of hash map. And by the way, this is why all my projects are really shitty when it comes to actually uploading them, is because I don't know anything. So I'm basically trying to make the most complicated and sophisticated projects with like 0 programming experience, and that's why these videos, they sometimes feel a bit dissatisfying, because I've spent 2 weeks on something that doesn't look that impressive at all, and it's just because every single thing I want to do, I have to then go and Google it, and then also I need to change this to Rust. And it just takes a lot of time to actually get familiar with everything. But that is the reality of programming. Is there an intuitive way to get the length of a hash map? Yeah, I can use map.keys.length. It's not the most efficient, but I think that overall a hash map is going to be more efficient, I think. Anyway, although, because we're kind of, I mean, it doesn't really need to be a hash map. I mean, this should probably be a hash map, because this is where we're actually accessing the data. So this would definitely make sense as a hash map. Although I think it's fine to do a vector. I don't know. This is what happens. I just go and I think in my head, and when I'm trying to actually do something properly, I would just be repeating it in my head over and over until I get something that I'm satisfied with. So yeah. Okay, bye Fondient. You are getting removed. Oh wait, can I only remove singular messages? Okay, you're getting hidden from this channel. Bye bye. Okay. Let's see. Yeah, we're sitting on 71 viewers. That might not sound like a lot, but that is kind of terrifying, because I can't just like edit when I make a mistake. Everyone has to see it. So yeah, you guys get to see me suffer live, which is awesome. Oh, we've just gone up to 76. That's awesome. Okay, so this has probably got to be like the most sadistic thing ever, is just streaming myself suffer and trying to code in front of a bunch of people when I have no idea what I'm doing. So let me just check my, yeah, okay, I'm recording as well, which is good. So I'll be able to actually edit this. Okay, so yeah, we got to the insertion, and then we're reviewing the leaf nodes, which is probably fine as a vector for now. The root, like these, the tree nodes, I mean, I think it's, yeah, I mean, no, it wouldn't make sense to make this a hash map, because we're never actually going to, when we're looking through these, we're never actually going to look at the the keys and try and find them with just a hash map search, because these aren't like the values that we're actually looking for. We're just iterating through these values and then finding which one we should traverse down. I hope that at least makes some sense, but hopefully as we do this, it'll make a bit more sense for you as well. Update your 5 extensions. Yeah, no. I'm gonna let my VS Code break because that'd be quite funny. Okay, so I'm actually going to try and write this in Start now. So let's change these because it makes more sense to make these just vectors. And then we'll just make them of this, and then we'll just say value i32 for this. So my original idea was right. This probably happens for you guys as well. But do you ever find yourself like you write a solution and then you're like, oh, that won't work, and then you go back to the original solution anyway, because that is something that happens quite often for me. Wait, I need to keep this, and then this just needs to be a hash map. Yes. And then, I mean, I guess it can just be, although, oh no, I already said this. This is what happens. I just like forget things I've already said. I'm probably stupid, but it's more entertaining that way, I suppose. Okay, so yeah, and then this can just be a vector of root nodes. That's absolutely fine. So the first thing we want to do is we want to say, oh, how do we do this? I suppose if self, and we also need to get the self. Also, I forgot, because yeah, we need to initialize these values, so we'll just derive default, if I remember correctly. That is how we do it. Very good. So now we'll have an empty vector for each of these when the class is initialized. We'll also go in here and we'll just say let mut, and we'll also need to make this a mutable reference, and we'll just say let mut bp tree equals bp tree defaults. There we go. And then we'll just do bp tree dot insert, and let's just say 20 for now. We'll also need to implement display, so I have to look up how to do that as well. Will you add .db support? I presume that's a file extension for db files. I don't really know. Probably not. We're probably going to keep it simple and just make this functional in a way that we can insert items and then it'll be stored on disk for now. I also am aiming to make this database quite efficient, because I think that if it's not efficient, then we've completely failed, because the whole point of using like a B+ tree, it's not for fun, it's because it makes the database a lot more efficient when we're actually searching items, because there are significantly less items that we actually need to look for. So let's say, we'll probably do something like if self.rootKeys .keys, oh this is gonna, oh wait no, because we changed it to a vector, never mind. If self.rootKeys.length is smaller than, yeah, I think if the root keys length are smaller than the depth, then we want to do self, and we'll probably return after this, self dot root keys dot push. Oh, and we also need to set a left and right. But this doesn't have a left and right yet because we don't have any more values. But we could just initialize our left and right and just keep it empty. That's fine. That works. Okay, never mind. Okay. So we'll create like an implementation. So we'll just say impl roots nodes, and then we'll just have like a function new, and then we'll just say I mean, for now we'll just give it the value, which is going to be an i32, and then we'll just return a self, so self, and then we'll just say self, where the value is obviously the value, and the left is going to be tree node item, but then we want to do a tree node item new, and hopefully that will initialize an empty value. Hang on a moment, I'm losing the plot. Hang on a moment. Bear with me. My mind has already had enough. We're 50 minutes in. Technically, for you guys, half an hour in. And I've already lost my sanity, which is awesome. Okay, so I'm just going to do a funny. There we go. Try making this in Plasma. What, the game Plasma, make a database management system. To be fair, if someone pulled that off in Plasma, I would genuinely be very impressed. Because this is really hard to do, regardless. Can you imagine what this would be like? I heard someone in the background, don't know what that was. Imagine what this would be like in Plasma. If you don't know what Plasma is, it's a very cool game. I would recommend it if you're a programmer. We're going off topic, but I need a break from programming for a second. Not the blood. We want the game. Okay, essentially, you get like a bunch of items and you can connect them together, and then you can write code for these different items, and you can do it in Lua or you can use the tree nodes. You can make some really cool stuff with it. Recently they hosted like a robots competition, where you basically had to compete with other people to make a robot with certain requirements, and then the winner, I don't know if they got a reward or a role or something like that in the server, but essentially you would there would be two robots and they would just fight to push each other off a platform, which I thought was really cool. But yeah, you can make some really awesome stuff. They also plan to add aerodynamics, which I'm really looking forward to, because that will make developing items a lot more interesting. But yeah, I really do recommend this game. I think it's definitely worth the price. You can spend hours just making random shit, and it's educational as well. It's useful. The postwoman is here, so I should probably go and get that. So I'll be back in just a moment. Never mind, she's gone. Cool. We don't have to worry then. Can you fuck off, please? Mr. Actually, I'm not gonna... You know what, just... Bye. Why are there so many children in my chat? How was your experience using WebStorm over VS Code? I actually, I think that WebStorm's a really nice piece of software for web development. In terms of using it for even TypeScript or JavaScript, I thought it was pretty awesome. So yeah, I would genuinely recommend. Why are you still in my chat? Yeah, no, it's a really good piece of software. It lets you refactor code and create new files and stuff like that really efficiently. So I would rank WebStorm over VS Code if you can get access to it. If you're a student, you can actually get JetBrains for free. So I think if you sign up for GitHub Students, you get a bunch of different perks that you can also get JetBrains for, and you can just get all the JetBrains software, I believe, until you're not a student anymore. I'm not sure about that one. Let's see. Okay, I've had enough moderating my chat. If it gets really bad, then I'll manage it, but it looks like this sad person's just gonna keep making accounts until I stop giving them attention, so let's see. Yeah, obviously I can't compare a U size to a U weight. Let's just make it a U size then, that's fine. Okay. So, my brain was melting at this, so let's try this again. Okay, so let's think about it. So we have the tree, we have a list of items. I mean, realistically, we want to create a new root node. So let me just try and think about this. So when we create an empty node, let's draw this with Miro. So when we create an empty node, we'll have like the root nodes here, blah 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 blah, and they'll have pointers as well. So let's just say 32, and then we have the left pointer and sorry, the right pointer and the left pointer, and then these will just point at the moment to empty lists. That's a good point, because we have to like deal with like references and all that jazz. Yeah, because it's just like an empty hash map for now. We want to push that empty hash map to the, I suppose we'll just create a insert new root node and split it up. So we'll just say this doesn't need to be public. Insert roots key item at 32, and then we'll just do insert root key self.insert root key. Oh yeah, we've also got to do and myself, and then we just pass in the item. That's fine. Yeah, that's already ugly as fuck, but it's fine. Can I lower down the background music? Is it too loud? Do you want me to lower that? Also, could you reduce your stream bitrate? Sure. Let me figure out how I can do that. Stream's current bitrate is lower than the recommended bitrate. I mean, YouTube's telling me to increase it. Wait. I should know how to do this. I literally made a video on compression. I don't actually know. I don't know if it's an OBS thing. Maybe I have to do it in my OBS settings. Let me see. Hopefully this doesn't break the stream. Let's see. Stream outputs. Streaming video bitrate. Oh, the mod will be unrecoverable, so I need to stop the recording, and then I mean, I can try increasing the bitrate and see if that improves it. Let's see. What was your recommended? 4500. Okay. Let me know how this is. Hopefully that's a bit better for you guys. If that doesn't work, I'll try decreasing it. But yeah, hopefully, yeah, I'm looking at this and the quality is absolutely horrendous. Okay. It's not stuttering, that's good. Hopefully that's improved it. Current bitrate is recommended. Yeah, it's not increased it to the full 500. I don't know. It's still skipping? Hang on a minute. Let me find out. I mean, yeah, it's probably gonna be my internet connection. Wait, is it better or is it worse? It's skipping. Okay. Let me try decreasing it then. I mean, we could put it at 2K. Yeah, there's going to be a lot of buffering. I do apologize, guys. Let me figure this out. This is like the first stream I've done in probably over a year, so I'm not going to be very good at this. Let's see. Let me try changing it to like 2000. This is going to be absolutely awful, but hopefully improves the viewing experience for you guys. Let me know how this is. This is what happens when British internet is a thing. You can hear me. Well, that's always a plus, isn't it? That hopefully will improve. I can see on the stream it is like actually suffering. Hopefully this improves. How's this? Is that improved? Oh yeah, I could change the latency. I forgot I could do that. Where the fuck do I change it? Oh wait, I can't change it because I'm streaming. Wait, let me end it and then start it again, and then I'll just change it to... Although, no, it's already at normal latency, so it can't really get any better than that. It's not freezing anymore. Okay. We'll try this out. Hopefully it improves a bit. Do apologize for this. There's not a lot I can do because this is like to do with my internet. But, yeah. It's still stuttering. Let me try restarting it. I'll be a second.